Okay, so I am going to talk to you something about a very kind of introduction about the science of electricity. I'm sure Anshuman Nag must have taught you about this, but I think for the topic which I'm going to cover, whatever the introduction I give you today is very important for me. So please pay some attention to it. Okay, and as you are aware, the title of this course is the chemistry for alternative energy. And this course discusses various pathways and methodologies available for the generation of electricity. I'm sure you are aware of that. Therefore, the essence of this course is the science of electricity. Why we are concerned about electricity? Because electricity is the most flexible form of energy available for the mankind. That is why we are talking about the science of electricity here. And according to me, this science of electricity is not purely chemistry, it is more of physics. It is not purely chemistry, it is more of physics. And this physics is the basis of computers, radio, telecommunication, household lighting, and even the ability of food wrap to cling on to its container. And this physics is also the basis of natural world. For example, if you take a zinc solid electrode, if you take a zinc rod and apply an electric field to that zinc rod, you know that you can dissolve zinc 2 plus into the solution. This says that by applying an electric field to a zinc rod, you can dissolve zinc 2 plus ions from the lattice into the solution. That clearly tells you that the forces holding the zinc 2 plus ion in the lattice are electrical in nature. That is why you are able to remove them by applying an opposite electric field. This says that this physics or the science of electricity is responsible for holding the atoms and molecules in their own world. And very importantly, it can even produce auroras, lightning, and rainbow. During the dry winter days, during the dry winter days, especially when you wear a polyester shirt, and when you try to take off the polyester shirt, you might have heard crackling noises sometimes during the dry winter days. And sometimes you must have seen tiny little sparks when you try to take off your polyester shirt. Whenever you walk across a carpet during the dry winter days, whenever you walk across a carpet to reach the doorknob, you might have sometimes felt a mild electric shock. And I'm sure you are aware of this phenomenon we are talking about. That is nothing but the phenomena of static electricity. And static electricity will be everywhere during the winter. Everywhere during the winter. For example, when you style your hair with a plastic comb, when you style your hair with a plastic comb, you might have seen, you might have sometimes seen your hair stand up on its own, like a crazy guy, like a freaky, like a freak guy, Sometimes it stands up on its own when you repeatedly style your hair with a plastic comb. Or sometimes when you try to take your hats off from the head, you might have seen the hair stand up on its own. These are all due to the phenomena of static electricity. And ancient Greeks were the first one who name and make a written record of this phenomena we have come to know as electricity. Ancient Greeks were the first one who observed this phenomena of static electricity before 2000 years back. Ancient Greeks observed that whenever they rubbed an amber stone onto a cloth, it could attract dry leaves. They observed it 2000 years back. Remember, amber stones are fossilized resins used by the Greeks in jewelries. It looks something like this. You might have seen it. And celebrities even use them nowadays to make very beautiful ornaments. And ancient Greeks observed that when the amber stones were rubbed onto a cloth, it could attract dry leaves, and by enough rubbing, it could even produce a mild electric shock. And there is an interesting story. There is a very interesting story connected with this amber stone among the Greeks. It happened among the Greeks, especially when the Greek women, when they go out for party, they used to carry an amber stone and a frog in their bag. And whenever they see, usually the men after heavily drinking, they will be in their own world. They used to be in their own world. And these Greek women used to get very bored. And what do? They take out the amber stone, rub onto a cloth, and then they touch that amber stone onto the frog. What will happen? So what used to happen is that the frog, out of pain, out of the shock, out of the electric shock from the amber stone, the frog used to jump very painfully. It also used to cry. And this painful jump of the frog apparently made this crazy woman very, very happy. This painful jump of the frog, because of the mild electric shock from the amber stone, used to make this crazy woman very, very happy. It was an interesting story from the Greeks. What is the moral of the story now? You might think that the moral of the story is your pain is your enemy's happiness. It is not the moral of the story. I wanted to tell you, whatever the truth behind this story, what is undeniable is that ancient Greeks were the first one who name and make a written record of this phenomenon we have come to know as electricity, which cannot be denied. The European scientists who lived in the 16th and 17th century, they did not know anything about atoms and molecules. They have no idea about atoms and molecules. But they were terrific experimentalists. They were terrific observers. They were terrific inventors. They had no idea about atoms and molecules, but they were terrific people, terrific experimentalists, terrific observers and inventors. And they observed that whenever a glass rod was rubbed onto a silk cloth, it acquired a charge. They observed it in the 16th century itself. And the charge acquired by the glass rod was opposite to that of the amber stone rubbed in the same way. The question is, how do they understood that it was opposite? They understood it was opposite because whenever they kept a glass rod near to an amber stone, they got repelled. And whenever they kept two glass rods rubbed in the same way, adjacent to each other, they got repelled. Whenever they kept an amber stone near to a glass rod, they got attracted. This way they understood that like charges repelled and unlike charges got attracted. And interestingly, they observed that different materials had different capability for acquiring this charge by rubbing. And this phenomenon, they named it as triboelectric effect. And they found that different materials acquired different types of charges. Some got attracted strongly, some got attracted mildly, some got repelled mildly, some got repelled very strongly. And based on this, they made a series called triboelectric series. And you can see in the triboelectric series, the human body tops the list, whereas plastic-based materials are in the bottom of the list. And whenever two materials are further apart in the series, they can quite easily charge each other. Whenever the two materials are quite apart in the series, they can quite easily charge each other. That is why when you repeatedly style your hair with a plastic-based comb, you can see your hair, your body is in the top of the list. Plastic comb is in the bottom of the list. They are far apart in the series. Whenever you style your hair with a plastic-based comb, what will happen? All the hair threads will acquire the same charge and they will start to repel each other. That is why they stand up on its own when you style your hair with a plastic-based comb. And this series gives you some kind of insight about what is called the static electricity. And I must tell you that it was Benjamin Franklin who gave an explanation to this intriguing phenomenon called static electricity. According to, remember one thing, that Benjamin Franklin had no idea about atoms and molecules when he proposed this explanation. According to Benjamin Franklin, every material had an invisible electric fire within, according to Benjamin Franklin. And the materials with more electric fire tend to be positive in the triboelectric series. Why positive? Because it can give charge. It can give that fire to another substance. And materials with lesser electric fire tend to be negative in the triboelectric series. Why negative? Because it can accept that electric fire from some other species. And according to Benjamin Franklin, whenever you bring together two materials, the material with more electric fire acquired a positive charge, and the material with less electric fire acquired a negative charge. And most importantly, Benjamin Franklin noticed that electric charge is conserved. Whenever you create some amount of positive charge, you automatically create the same amount of negative charge. Therefore, electric charge is a zero-sum game. Charge is conserved. Benjamin Franklin understood that. And I must tell you that Franklin did not have any idea about the origin of this electric fire, but his idea was elegant and brilliant. We must accept that. I must tell you that electricity pervades our life. Electricity pervades our life much more than Franklin knew, and much more than most of us realize. Electricity is responsible for whatever we do, think, whatever we feel. Electricity is responsible. We can think, feel, muse, wonder, and romance because of electric charges jumping between unaccountably large number of cells in our brain. We can breathe because of electric impulses produced by the nerves, cause our chest muscles to expand and contract in a complex symphony of movements. The question is, how do you see your girlfriend or boyfriend? What is the science of vision? How do you see your girlfriend or a boyfriend? The tiny little cells in our retina, the rod and cone cells. The rod and cone cells pick up the black, white. Whenever you look at, for example, your girlfriend or boyfriend, the tiny little cells in our retina, the rod and cone cells pick up the black, white, and the color and form an inverted image in your retina. Something like this. It forms first an inverted image in our retina. Once this happens, the retina gets stimulated and it shoots off electrical signals through the optic nerves to the brain to correct that inverted image. It shoots off electrical signals through the optic nerves to the brain to correct that image. That time only you will realize that you were not looking at your girlfriend, but you were looking at someone else's girlfriend. So electricity comes into picture here as well, undoubtedly. Because of electricity, horses run, dogs cry, and the cats stretch. And the list is so extensive that it is so exhaustive that there is really nothing we can imagine without electricity. Far-reaching implications of electricity can be seen in the life of rattlesnake. It's a blind snake, it cannot see. This is the rattle of the, you can see there is a kind of spring-like substance, that is the rattle of the snake. And whereas you can see this is the head of the rattlesnake, and this is the rattle of the rattlesnake. This portion is the the rattle of the rattlesnake. And the rattle, the snake can vibrate the rattle in the air. The snake can vibrate the rattle. And in 1994, Dr. Theodore Wenstille from the US Environmental Science Center wrote in an article in Nature. He wrote in an article in Nature that the vibration of the rattle, the vibration of rattle means this portion, okay? The vibration of the rattle creates a static electric field in the body of the rattlesnake. And the rattlesnake can move the tongue back and forth. Therefore, the tongue also will have the same electric field. And this electric field is found to be positive in the case of rattlesnake, which means the tongue also will have the same positive electric field. And this back and forth movement of the tongue can easily detect the electric charge outside. Because if the outside is positive, since the tongue is positive, the snake will experience a repulsion. If the outside is negative, since the tongue is positive, it will feel an attraction. This way he can see the snake can scan the area and sense the area, even though the snake is blind. And you know that water carries an electric field. Water carries an electric charge. That is why you might have heard about it. Water can be bent. For example, if you take a plastic comb and comb your hair repeatedly, and you bring that comb near to the water pipe, it will bend the water. It is well known because water carries an electric charge. And most of the prey of the rattlesnake, like small rabbit, small rat, they used to exhale moist air. They used to exhale moisture, which means water vapor containing air. And water carries an electric charge. Please keep that in mind. If that prey happens to be near the rattlesnake, what will happen? Since the rattlesnake moves the tongue back and forth, the rattlesnake can easily detect the presence of water because water carries a charge. The moment water vapor is there, it will pick up that signal and the snake can detect the exact location of the prey without actually seeing it. So you can see electricity provides food for this poor species. If you take the case of electric eel, which is another blind fish, its body contains thousands of tiny batteries and it can produce even voltage up to 600 volts. I mentioned this one in one of the previous lecture, I remember. Not for you people, but for a different course. And if you are smart enough, you can light up your Christmas tree with an electric eel. People have done that already. And this is an encounter between a giant alligator, a crocodile, and a small electric eel in the wild. It was captured by the Discovery Channel. And the alligator was trying to eat the electric eel, and the consequence can be seen here. The alligator has gone into the heaven. So whenever you play with an electrochemist, you have to be very, very careful. He may be small, but he can be very dangerous. Now, recently, scientists from the Vanderbilt University found that electric eel can coil around the prey. And when it coils around the prey, what happens is that they found that the electric field experienced by the prey gets amplified by 3 to 4 times, leading to instantaneous killing of the prey. But interestingly, nothing happens to the electric eel at all, and nobody knows why, even today. And recently, scientists have modeled the batteries in electric eel. These batteries are biobatteries, sometimes called as electroplates. They modeled the batteries, these electroplates, in an electric eel, and they found that from the head of the electric eel to the tail, from the head to the tail. In one row, they observed 5,000 such types of batteries, 5,000 batteries in one row. And they found that there are 140 such rows. And each battery can produce an electromotive force of 0.15 volt. And it has got an internal resistance of 0.25 ohm. They have already measured it. But what is interesting here is that this phenomena of electricity is a kind of defense mechanism for the species. It provides food for the species, and that is why the species is surviving in this hard ecosystem. So electricity provides into their life much, much more than we can imagine and we can think. And I'm towards the end of my lecture. I'm sure Dr. Anshuman Nag has taught you the physics of solar cells. Dr. Anshuman Nag has taught you the physics of solar cells. And that is nothing about the physics of light harvesting. Physics of solar cell means the physics of light harvesting. And what is the most important application of light harvesting? Artificial photosynthesis. Artificial photosynthesis is the most important application of light harvesting. In natural photosynthesis, plants capture sunlight and convert the energy of the sun as glucose. In natural photosynthesis, plants capture sunlight and store it as glucose, store it in the chemical bonds of glucose. In artificial photosynthesis, what we do is that we capture sunlight using a solar cell and split water into hydrogen and oxygen. We store it in the chemical bonds of hydrogen and oxygen. That's what we do. How? By splitting water. What we do is that whenever sunlight is available, we capture it by using a solar cell. How? We capture it and store it by splitting water into hydrogen and oxygen and store them in cylinders. You can see here, store them in cylinders as shown here. Okay. And whenever the demand is high, demand means the demand of electricity will be high in the night time. That time sunlight is not available. So what do? You combine this hydrogen and oxygen in a fuel cell. You combine this hydrogen and oxygen in a fuel cell and generate electricity. How does a fuel cell generate electricity? You can see here, hydrogen undergoes oxidation on one side. And what happens? It undergoes oxidation means H plus and electrons will be released. Electrons will move through the circuit. When it moves through the circuit, we get electricity. And on the other side, you have oxygen. So these electrons, H plus and oxygen will combine, and at the other side, you will form water molecules. This is very important. You can see the byproduct of electricity generation in a fuel cell is water. And you can see if you go back, you start with water. You can see here, you start with water molecules and you end up with water molecules here again. You end up with water molecules here, which means there is no emission of any greenhouse gases during this entire episode. There is no generation of greenhouse gases during this entire episode. That is why all the industries all over the world are trying to make fuel cell powered electric vehicles because it's a kind of zero emission or zero polluting energy technology. And the science of electricity connected with batteries, fuel cells, supercapacitors, and waste heat harvesting will be the focus of my talk from tomorrow onwards. And I will try to cover first very briefly the fundamentals of electrochemistry first from tomorrow onwards, because I'm not sure how many of you have taken the electrochemistry course in the August semester. And I would like to cover very briefly the fundamentals of electrochemistry because that is very, very essential for you to understand this science of electricity connected with batteries, with fuel cells, with supercapacitors, with waste heat harvesting. thermoelectrochemical cells, etc., etc. That's very important. Those fundamentals are important. So tomorrow I'll cover very briefly the fundamentals of, very briefly about the fundamentals of electrochemistry, and then we will move on to uh, all these topics, interesting topics. I'll wind up here today, and you can ask me if you have any questions.